on number 5. Did start with a natural log, but ended up with a natural log because there was x to the negative 1. We've done trig. We had a couple trig on there. I think we have the number 8's the last one. On the last one on there is also a trig. Yeah. The function that we didn't do, haven't talked about, is e. Okay? So e always has powers, right? E always has powers of whatever, right? Like this guy. This guy has a power of negative, it's negative 1/5 x, right? Or negative 0.2x, okay? E is known for having powers because it's exponential. So the way you're going to do this one, there's a couple different ways to do it. There's not just one way, but I'm going to show you the way I would do it, and if it makes sense, do it. If it doesn't make sense, you can do it whichever way you think makes more comfortable with you. So what I see is, I see this minus. I have 8e to some power, and then I have minus 8, right? So I'm going to do what some of you guys did on your quiz. I'm going to break those up into 2 smaller parts, because they're 2 terms joined by a minus. So the first part is this, dx, and the second part is the same bounds, right? Just 8. Do you have to do it this way? No. But I think it's going to be easier when you can just focus on one part versus the other and not have to worry about both. Okay? So isolate that guy, and it's a minus in between. Okay, so let's focus on the easier part. This part you've already had, right? Some of you could probably do this one in your head. Oh my. Does anyone know what the area is going to be for this guy? 40. 40. Mm-hmm. The function is 8. It makes a box, 5 wide, 8 tall, 40. Okay? If you're not sure, draw a picture. Some of you did that on your quiz last time. I would suggest doing that. Okay? So that's just going to be 40, minus 40. Oh my. We're going to kind of put that to the side. We're going to kind of put that to the side right now. This is the part we're going to deal with that's going to take us a few more minutes to do. Okay? 8e to some power. Well, first of all, the 8, you can move to the front if you want. You can leave it there, but you can move it to the front because it's a coefficient. That is totally okay if you want to move that. I would probably move that to the front so that it doesn't get mixed up with anything. Okay? 0, 5, e to the negative. So like I said, e always has powers. And those powers usually are the variable. That's what makes it exponential. So when you're dealing with e stuff, the power is going to be your u. That's what's going to be most likely if you need to do u substitution with e stuff. Where is the u hiding? Up in the power. Okay? Most of the time when you're dealing with e, anything e related, if it's just x, if that was just 1x, you wouldn't need to do u substitution because the antiderivative of e to the x is e to the x. But what makes it different is that the power is not 1x, it's negative 0.2. Anytime the power is something other than 1x, you need to do u substitution. And where is that u going to be? Up top. Okay? So I'm going to do u substitution for this guy. So u is negative 0.2x. What would its derivative be? Negative 0.2 dx, divide both sides. So here's the thing. Negative 0.2, I don't like dividing by fractions, so I'm going to change it to what it actually is. It's negative 1/5. So instead of that, I'm going to rewrite it as negative 1/5. That'll make it easier when I divide. Instead of dividing by negative 1/5, I'm going to multiply times 5. Or negative 5, sorry. So it's going to make it negative 5 du equals dx. Because I multiplied times the reciprocal. Okay? All right, so let's go back, move everything back in. So we get 8 in front. Integral. E is still E, because I didn't do anything with E. U was its power. So now its power is going to be U. And du is negative 5, or sorry, dx is negative 5 du.
Oh, okay.
Multiply the negative 5 times the 8 on the outside. Again, do you have to do that? No, but make your life easier by getting rid of that. And not get rid of it, but move it so you don't have to deal with it while you're finding the integral. Okay. Okay, so let's do antiderivative now. Negative 40. The antiderivative of e to the u is just itself. It's 1u. It's like 1x. So it would just be itself. And then you're going to evaluate that from 5 to 0. Okay. Move u back in. So negative 40 e to the negative 0.2. You can keep it as a fraction or you can do it as a decimal. It doesn't matter. Okay. Last step, plug in 5, plug in 0, subtract them. So I'm going to plug in 5. Plug in 0. Okay. So negative 40 times e to the, this would be negative 1, because negative 0.2 times 5, or negative 1/5 times 5 is negative 1, minus negative 40 times e to the 0. E to the 0 is just 1. So that's really just negative 40. And so it's really this, right, because it's minus a negative. So negative 40 over e plus 40. You can factor out a 42, but it's not necessary. Okay, so that's that. Yep. Add that to the other. Bring this guy down that we haven't even talked about for a while because we put it to the side. Minus 40. So the 40s will cancel out. So 40e plus 40 minus 40. The 40s cancel out, and you get negative 40 over e.
No, my 40s. Yeah, it's 140. Yeah, but it's negative. So.
Okay. So anytime you're dealing with anything E related and you have to do an antiderivative, look to the power for the U. If the power, if it's just E to the X or E to the U, you don't need to do U substitution. But if it's anything other than X, that's where your U is going to be. More than likely, that's where your U is going to be. Okay? When you're dealing with anything E related. All right. All right, the last one is another trig. I wanted to put one more trig on there to help you there. First question, my first question before we do anything, do I need to use U substitution on this, or can I just use the power rule? I know that the antiderivative of sine is negative cosine, right? Do I have to use U substitution? Or can I bypass that and just use Just not use it. So just the regular power rule? So let me ask you this. If you're not sure, this is how I do it. Go back last semester. Let's say I was doing this and it says derivative. Find the derivative of this. Would I need to use the chain rule? Yeah. So if the answer is yes, then the answer is going to be yes, you need to use U substitution. Okay? That's how I do it. When I look at it under that lens. It helps me decide whether I need to use the power rule or the chain rule, right? Because for antiderivatives, we have two rules. Power rule, U substitution. For derivatives, we had 4 different rules. And if I can't use just the plain power rule, I do U substitution. Okay? What's U then? 2x, yep. Inside the parentheses, U is going to be 2x. That's the hardest part about this problem. Once you get there, everything else just flows. Divide by 2, divide by 2. I get 1 over 2 du equals dx. Move everything back in. Instead of sine of 2x, it's sine of u. And then move in dx, which is 1/2 du. Move the 1/2 to the front. Antiderivative. Now I can do power rule because it's just sine of u or sine of x or sine of anything. It's just a variable, 1 whatever, right? So now the antiderivative of sine is negative cosine. So you have 1/2 negative cosine times negative cosine of u, and you have to evaluate that from pi over 4 to 0. Move u back in and multiply, so it's negative 1/2 cosine of 2x pi over 4, 0. Plug in pi over 4, get an answer. Plug in 0, get an answer. Subtract them. You're done. Negative 1/2 times cosine of 2 times pi over 4 minus negative 1/2 times cosine of 2 times 0. Negative 1/2 times cosine, if I go 2 times pi over 4, that's 2 pi over 4, which is the same thing as pi over 2. And then 2 times 0 is just 0, so it's really just cosine of 0. I'm going to do the cosine of 0 one first because that one's, cosine of 0 is just 1. So it's negative 1/2 times 1, so negative 1/2. And what's cosine of pi over 2? So it starts up and then hits 0 and then goes under, right? So what is the what is cosine of pi over 2? 0. It crosses at 0 and then goes under.
No, because at pi it's negative.
At pi it's negative 1 and then it comes back up.
Oh.
Okay. So you get 0 minus a negative 1/2. You get positive 1/2. Done. I'm telling you right now, the hardest part about a lot of these is where do I start? Is it U substitution? Is it power rule? Which one do I start? Because once you get that going, I saw a lot of you, once I said it's a U substitution problem, a lot of you just went right to work and you knew what to do, okay? So the hardest part about that is U substitution or power rule problem, okay? Getting more comfortable with that. All right, so find some space. I'm gonna give you, let's do one problem at a time. So I'm gonna give you one problem and then I'll give you another problem. So we'll call this number 9. Okay, try that one.
One over. Oh wow. So 2x 2 over 3.
Okay, so if you're still working, keep going, but I haven't finished U substitution, but I got through most of the steps.
Yeah.
I rewrote it because I had a root. Most of the time, you're gonna find a U, because I can't distribute. Because I can't distribute this guy here, so when you can't distribute, you're gonna have to do U substitution. The key is which one's U? Well, the bigger power. Look for the bigger power, and it's in parentheses. That is most likely gonna be your U. Okay, so then I did U du divided by the derivative, and I got this. Put everything back in. The x squareds cancel out, which I wanted them to do. I have a 2 divided by 3, so I made it a 2/3. And since it's just a coefficient, it can move to the front. My next step is to actually do, now that U substitution I've substituted in, now I have to do the antiderivative, okay? So I get 2/3. It's gonna be U to the 3 over 2, because I gotta add a power. And then I'm gonna divide by that same power, but instead of dividing by a fraction, multiply by the reciprocal. The reciprocal is 2 over 3. And then I have to evaluate it from 2 to 1. So 2/3 times 2/3 is 4/9. And then U is x cubed plus 1 to the 3 over 2 power. And then I have a 2, I have to evaluate it from 2 to 1. Okay? Plug in 2 for x, plug in 1 for x, simplify as far as you can, and you're done. So I get, first one, 4/9, 2 cubed plus 1 to the 3 over 2 power, minus 4/9, 1 cubed plus 1 to the 3 over 2 power. Okay, simplify. So I get 4/9. 2 cubed is 8, plus 1 is 9, to the 3 over 2 power. minus 4/9. 1 cubed is 1, plus 1 is 2. Okay. 3/2 power. 3/2 power means cube it and then square root it, or vice versa. Doesn't matter which one you do first. So if I would say square root is easier to do because the square root is just 3. And then you cube 3, you get 27. The other one is the same, but I would cube 2 first and then take the square root, because the square root of 2 is 1 point something. It's not nice. It's not a nice number. So cube it. If I cube it, it's 8. And then if I take the square root, that's square root 8, which is still not a nice number, but I'll deal with it.
Do you actually cube 4? I wonder what it actually.
Okay, so multiply negative or 4/9 times 27. Well, you can divide that by 9 and divide that by 9, so you get 12.
Oh, I did not do that.
So the simplest way, if you want to go in simplest form, you got to reduce this guy. So how to reduce it? Well, 8 is 4 times 2. And the square root of 4 is 2. So it's 2 root 2.
No.
So we get 12 minus, yeah, and then you have 4 times 2 is 8, square root 2 over 9.
I guess.
And I'm good there. You can do common denominators, but it's not necessary. As you can get there, I'm happy.
What a fun answer, am I right, guys?
Okay. Okay, here we go. One more and then we'll be done. One more, yeah, and we'll be good. Okay, so let's see. So do you want an E problem or do you want a natural log problem?
Natural log.
Natural log, okay. It's got E's in it, but not the way you think.
What?
Natural log, okay.
Why are you green?
I think E's are easier, but I'll give you natural log.
Oh yeah, it is a book.
Okay, last one.
Ah! No, we're fools. I need like a natural log.
Okay.
E squared. One. Naturally log x.
Come on, bro, log in.
This is not done. Wait, no, natural log of e is just 1, right?
Watch. Here we go. Let's see.
Wait, so what are we doing different then?
Natural log of x, right? Oops. Right? Okay. So the derivative is, du is 1 over x dx, right?
Yes.
Multiply both sides by x.
Yeah.
And then move everything back in.
Yes.
And then it still becomes u to the minus 1.
I'm still saying.
U to the negative. Oh, I see what you're saying.
And I
Okay.
got natural log, and that's
Okay. I see what you're saying.
Alright, so what do we do different now?
I was talking about later. Okay, so watch. I'll do it. Let's look. When we get there, we'll worry about it. But let's look at this. Okay. I'm not there yet, so let's do this.
Yeah.
Okay. U to the negative 1 d. Oops, not du. Negative 1, and then I have to move an x du, right?
Yes.
The x's cancel out. If you can do that, that's good. Okay? That's what I want. Now, later on, we're going to have a negative 1 where you're going to have a natural log of a natural log. That stuff, you won't see a lot. But so most of the problems, if you can get here, I'm okay with it. Okay? So let's keep going to see what we got. So we get u to the negative 1 du, right?
Uh-huh.
So this is where we're going to have natural log, right? So we get natural log of u, and then it's going to be from e squared to e, right?
Yes.
Okay. So this is a good thing because it's not as hard as you think. Let's see, natural log. So it would be natural log, and then there would be a natural log in here, right? It's not as hard as you think, trust me. That's why they give you e's for these guys. Well, I didn't know you were this far. I didn't know you were this far. I thought you were up here. I thought you were still doing u substitution. That's what I thought. No.
No, because it's not the mix.
Okay.
No, it's not too many steps.
Okay, here we go.
Three. I can do
Natural log e squared, right?
Yes.
Okay. The natural log of natural log for regular e. Okay. All right, so let's start this. So first thing we're going to do is go on the inside, right? What is the natural log of e squared? I don't want to erase this, but let's see. So what I'm asking is this. When I write it down, it probably will make more sense. So natural log, yep.
Ah, I see. E to what power is
Right? E, because it's really log base of e squared equals what, right? So really what you're saying is e to what power equals e squared?
Ain't no way. Wait.
2, right?
Oh, no, then we have to find the natural log of 2.
That makes sense.
And then the natural log of e is really log base of e. So it's really e to what power equals e? 1. Natural log of 2 is some decimal that I'm not going to worry about, so I'm just going to leave it natural log of 2. But what's the natural log of 1? 0. There you go.
Yeah, they mean the natural log of the natural log.
Okay? So knowing those natural log things or regular log things, right? That helps make this problem go faster because you know those things. So yeah, if you have a natural log of e, the power is always going to be the answer.
Okay.
Natural log of e, the power is always, that's the quick way to do it. That's the shortcut. Okay, that's the shortcut. And if you have natural log of something else, leave it. If you have natural log of 2, leave it. Don't try to change that or anything. That's as far as it can simplify. Without a calculator, that's as far as we can simplify. Okay? And then log of, anytime log of 1, natural log of 1, that's always going to be 0. Right? Okay? All that stuff. All right? That is by far how hard they get. Okay?
This is from this year, bro.